Question 3 is calculating the empirical formula from a percent composition. And question 3 states, in the theoretical compound that contains 15.1% lithium, 18.4% bromine, 31.7% iodine, 9.2% calcium, and 25.6% sodium, what is the empirical formula? And as we know, the empirical formula is the number of atoms of each element and the ratio of the number of moles of each of the elements. And so for these problems, we're going to be assuming that it totals 100 grams, so we can automatically change these percents into the grams. And to start off, we'll start by changing each element into moles. So here we'll start with lithium. And since we were given 15.1%, but we're assuming 100 grams, we can change that just to 15.1 grams. Okay, and now how to get this into moles, as we know, is we just take the grams of the element and then we multiply it by its molar mass. And so in 1 mole, there is 6.941 grams of lithium in 1 mole, and that's taken from the periodic table. And as we know, the reason why it's 1 mole over grams is because we can cancel out these grams and find the moles here. So once you do 15.1 divided by 6.941, we are getting that it is 2.175479 moles of lithium. So just for now, we can stop with lithium and move on to bromine. So here we'll take bromine, and we're given 18.4%, which we can change to 18.4 grams. And its molar mass is 79.904, and we have that many grams in 1 mole. So you take 18.4 divided by 79.904, and we get 0.23027 moles. Okay, and then we can move down to the next element of iodine. I'm leaving some space here. We have 9.2 grams, and in iodine it has 126.90 grams in 1 mole, or that's its molar mass. So we can cancel the grams out. Sorry, I didn't do that for this one. And just divide that out. And I wrote that wrong. I see I made a mistake. In iodine there's 31.7. I just had read the wrong one, but here we have 31.7 grams. But this is the right molar mass. And once you divide that out, you get 0.2498 moles. Okay, and then we can move on to calcium, which is 9.2 grams here. And calcium's molar mass is 40.078 and 1 mole. You can cross out the grams here. And we get 0.22955 moles. Alright, and we can do the last element, which is sodium. And here we are given 25.6 here, and its molar mass is 22.990 and 1 mole. Can cancel out the grams and divide that out, and this is equal to 1.1135 moles. Alright, and now that we've found all the moles of each of the elements, we want to find which one has the smallest amount of moles. And here we are given, if you look through them all, calcium has the smallest amount. So this one would, technically it could be the limiting reactant, which is why we're going to be dividing it by each of the other elements to get its molar ratio. So now that we have found the molar mass and the moles of each, we are going to be calculating the molar ratio. and we do that by dividing the smallest number of moles from the element in each of the elements. So we'll start by dividing lithium's moles by calcium's molar mass here. I'll put a star. So we divide that out by 0.22955. And here we are given, or it's calculated 9.7, or we can round that up to 9.5 there. Okay, and then we just divide the same one by calcium, or we divide bromide by calcium, 0.22955. Calculate that out, and that's 1.003. Move on to iodine, and we divide that as well, and that comes out to be 1.08. Then we do the same for here, so we divide it by itself, so of course it's just going to give us 1. And we also divide sodium by the calcium moles, 0.22955, and this gives us 4.84. Now, to get the molar ratios, we want whole numbers, and as we can see, we have decimal points here, so we can just round those off. And whenever you have a decimal with 0.5, that's not 1.5. Here we have 9.5. They get rounded up, so that gives us 10. 1, this just is 1. Another 1, obviously 1, and then this gets rounded up to 5. So, in taking the empirical formula, we just write out the elements here. And here we are given that it has 10. And then we have bromine, just 1, so we leave it. Iodine with just 1, so we leave that as well. Calcium with just 1, and then sodium with 5. And that is the empirical formula.